Welcome back to Made Up of Wires, where we are decompiling Castlevania Symphony of the Night. As always, you can learn more about the project at soten.z.dev. Be nice if I had that up for you to see. We've been working on Doppleganger and both 10 and 40. A little trouble yesterday with one of the functions that I pulled out that has 4 variations between those 2 bosses. And so I was hoping solving one would solve all 4, but the one that I picked proved to be tricky, and so I wasn't able to get it. We'll look at some more stuff there, but before we do that, one of the things that I wanted to do was look into a mod for the chair, and just looking at the mechanics of the chair and some of the other things around that. So when you are when you're going through the level and you come, or the game, and you come across different chairs in the game, you are able to sit in them. And let me pull up Duck Station. And Alucard will sit there, and after a while he will start to sleep, and you get this nice little Z animation. One of the things that I want to do is change the sleep Z's to health restoration. And so I was looking into how this is done, and I'm going to set a breakpoint. I'll show the debugger as well. So we know where the code is for the sleep Z's, and I've added a breakpoint there. We look at the registers to see what the address of the entity is for the Z's, and that entity is 7621C, and I happen to be right around there. And the entity ID is what is used to determine which entity update function is going to run. And so one of the things I wanted to do, just to see this working and what it might look like, was to set a breakpoint at the return address of this update function for the Z's. So this is going to be allocating any polygons for the Z objects, and there's actually one entity for each Z that pops out of Alucard's head. So I'm going to go to the end of this, and I'm going to change one of those. Instead of entity 66 hex 42, I'm going to change that to 13. I'm going to change the step back to 0. 0 is the step that is usually used to allocate any primitives associated with the entity. I'm going to get rid of these breakpoints, and what we'll see now is entity 13, or 13 hex, which is 19, is the entity for the health display, the little number that shows up before. And we didn't set any of the parameters or anything like that for the health display, so we'll see what the default state is. So when I unpause, we should see that, and we get the 0, and the 0 goes up to health. And so what I want to do is replace that. And so I need to do a little more research about what those functions are and how they work. And so let's dive into that a little bit and see how this all works. So let me flip over to, need to stop a YouTube video that restarted in the background somewhere. Give me 1 second. When Safari restarts, it tends to autoplay videos, which is pretty frustrating. Especially because I have a million tabs open and a million windows open. So I get a million videos that start playing. One second, excuse the delay. Oh, come on. Well. Of course, Safari's not responding. So, I'll keep going and then we'll see. We'll see what happens. Usually I can also just disable sound for a tab, but this is frozen. So anyway, let's go and start looking at some code. So the first thing I did when I was looking at this, and I'm gonna have to break this out into a few things. Usually my terminal is much bigger. I started with the chair, and I wanted to see what oh, now I have a million different things going. Hey, Antoine. Hey, Roaming. Good to have you back. Can I pause these now? Just have to kill Safari. How frustrating. Anyway, hopefully you're not hearing all this jibber jabber in the background. It's like I have voices in my head. So we have the chair entity, and eventually what is going to get called is this entity player sleep Z, and I haven't figured out where in this call chain this function or the entity for this is getting set, and so I need to work on that a little bit before I do this. It's frustrating. All right, so we have this entity chair, and one of the things I noticed almost immediately was this gplayer unknown 14 getting set. If we look at the chair state machine itself, it's by the accent I think he's a German. I'm doing some Blender work on the side and watching a bunch of Blender tutorials about rigging. Dig down deep, I'm sure could find the dialect immediately. Entropy Gravity, well, good to have you. So if you look at the entity for the chair that we decompiled several weeks ago, there's really not much here. We initialize the entity. The entity is just common. There's nothing specific to it. This gplayer unknown 14 is really the only kind of unique global thing. There's stuff up here about the pad, the simulated pad, gamepad. This function here is checking to see if the player has pressed up or not. But other than that, there's not much. There's some state internally, but it's not allocating. It's just using background tiles, so it doesn't have to allocate any polygons, primitives, or anything like that. So I looked for gplayer unknown 14 to see where this is being used, and what I found was it is being used in this one DRA, actually a couple DRA functions. And right now the case is whether or not the player is standing. as far as I can tell, these all have to do with the chair and transitioning between sitting and standing. And when we go into standing, somebody's already come through and identified this chair sleep timer. And we get 1,800 frames. And that's 30 seconds you have to be sitting in the chair, which is quite a while. So then looking at this Alucard chair sleep timer, we can find where that is being decremented, which is here. And then we're using the create entity factory from entity function to create the Zzz. And this is where I'm, as far as I've gotten so far. And what I need to do is figure out how are these parameters? So right now, the identifier that we have for this first parameter for factory is ID, and the second is params. And in this ID, we actually pack a bunch of data that is used by create entity factory from entity, and we can look at that function in a second, how that data gets unpacked. 122 in hex is 100010. There's another one. The 9th bit is a 1 as well. This is a 16-bit value up here. And what somehow, let me get back to this function, or this file. Somehow, oh, did I open the same one? I did. We need to derive the hex value 42 from this 122. So somehow passing in a 122 as the factory to create entity factory from entity is going to create a new entity with this entity update. And looking at a hex editor, 42 is basically in the second nibble. It's an off by 1 to get that. So I'm not sure how that works yet. So let's look at create ent from entity. And this is a stage function. I thought it was create ent from entity. Let's create ent factory from entity. And we want where this is being defined. It's I was looking for void, but it returns an entity star. And it looks like it's in the 7897C, which I think is open already. So factory params comes in, and it is a 32-bit value, and the parameters that we're passing in look effectively like this. We have, so we're passing in 122, all right? At the top, we have 0, 1, and then 2, 2, and then sorry, 0, 0, 0, 1. That's our first octet. And then first byte. And then our second byte is 02. Nope, that's not right. First byte is 0, 0, 1, 2, 2. And then the bottom 16 bits is going to be zeros. So we can kind of keep this in mind as we're going through. That's what our factory params are. So the first thing that happens is we're masking factory params, just the bottom 12 bytes, sorry, bits. So that becomes this value, 220000. And we're checking this against this mask 5 and 5000. I'm not sure. Oh, factory params. Yep, that would be fine. And this will be true because this one here will mask correctly. So our unknown A8 will be EO. And then we're masking its A1000, which is 1010. That will not match. And so we'll keep our A8 as E0. So then we'll come through and unknown A0, we're going to shift these values over by 8, masking just these. So this is going to end up being 22 hex, which is 34. ARG2, oops, that was right there. ARG2 is 0. So this will be 0. Flags, we already said what, oh no, we haven't figured out flags yet. Flags is coming from the source that's creating this. And that is the current entity. The current entity is not the chair. I'm not sure what the current entity is yet, so we might not know what the flags are yet. Let's see, factory params was 01220. So this, our lower 16 bits is all 0, so all of these are going to fail. And then we return the new factory. So nothing in here yet is particularly telling, except for the values that are put into unknown A0 and params. Those are the only things that differentiate this from anything else. So we might be able to use that information. I'm going to set a breakpoint on create end factory from entity. Hopefully this isn't being called by anything else during this game loop. And we can get the offset for that. And now I'm going to go back into DuckStation and enable all the things. And I'm going to add this. So it'll be a while before we get Zzz again, but we should get them eventually. And let's wait till we hit it. And we've hit it. And so we need to, we can double click here and this will take us to the offset, but that's not really important. What we want is the source entity, and that'll tell us what the entity ID is of the thing that's creating this entity factory and what the offset is. So we get that here. Unfortunately, DecStation doesn't recognize that this is an address, so we have to just scroll through and try to find it that way. And it's going to be in the entity table, so it's a known range of addresses. So 8, we don't ignore the 8 and then just look at the others. 7, 3, sorry, yes, 7, 3, 3, D8. Seven. I'm way too. Seven, 3. 7, 3, 3, D. 8. So now we need to know what is the structure of an entity to be able to figure out what offsets we need to look at. The first 16 bits is actually the first 32 bits is position X. Next 32 bits is position Y. We need to go about to get the entity ID. It's going to be 26 bytes in. So 733D8 plus 26 hex is 733FE. I think it's 26. Let's look. .26 will be the entity ID. So we go to the E column here. And 773FE is 0, which is the player. And so the player is the parent entity, and that kind of makes sense. So we can look at the next entity, which is passed in actually, we don't have a another entity passed in. We just have the factory params. And looking at the factory params, 7A, let me just make sure that that is 122 like I expect. It is. And then arg2, which is the other param, to create end factory from entity is 0, which is what is expected as well. And so I'm going to look at the return value, which will be in V0, and just step through this and watch V0 before we get to the end. And take a look at the entity there. Just make sure that the params and flags are what I expect them to be. So I'm going to scroll down, looking for this return value, and I'm going to add a breakpoint there as well. So we know all the logic of the function has happened by that point, and I don't have to step through, and we can go. And then, so V0 is going to be the address of our entity that we're returning, 739B8. And you can scroll there. Find that 739. It was there, 739B8. And we'd do the same thing. So 739B8 plus 26. Is DE. And our entity factory ID is 1, which is fine. And what I am interested in is what is the params and flags. And I just want to make sure that I calculated those correctly. Params is going to be, there's the next value is going to be a pointer, so 4 bytes, and then another 4 bytes for step and step S, and then params. And then params is 16-bit, another 16-bit value, and then flags. So we have 8 bytes to jump over afterwards. So this is the entity update function, these next 4 bytes. There's nothing there at the moment because this is an entity factory. The next 2 are the step, which is set to 0, and then step S. And then 7A is params, which is 122. And what did I say? I said 22 because this was being masked. Oh, yes. Okay, I was wrong about the 120. 122 is decimal, and I was treating it as hex. So 7A is correct, and that's what's being passed in there. And then for unknown A0, I'll fix that. So that was the 7A. It's going to be 7A00 for that value. And A0 is how far? I'm assuming it's going to be A0 away, but I might not be correct. No, A0. That is in the entity extension portion. But that is, I think, correct, that will be A0 away from the start. So I need to go back and find the start of that again, which was 739B8. Seven 398. Seven 3 A58. And 7-3 A58 is 0, which is not what I thought it was going to be. And let's try to figure out why. I also thought that A8 was going to be 5-0, and that is also not correct. But And why would that be? I was wrong about what those bytes were coming in. Let me fix that. Got the 7A0000. And let's mask that with 5000. Okay, so that does not work, and 7A0000. Masked with 8000, that should mask. Oh no, it's too low, too low. So yeah, none of that will mask, and anything in the lower 2 bytes is going to fail, because that value passed in was 0. All right, so flags, is flag set here? Source flags are set, and so the only way that we're going to set the factory flags is if source flags has this unknown 1000. So yeah, params ends up being the only, oh no, we have this one, this 8000 as well. So if we take our 7A0000 and we AND it with FF0000, that gives us the same value. And then we're going to shift that over by 8. Which gives us 7A00, like I thought. And so where is that down here? I don't see where that is set. And there's unknown A0. So I'm looking through the debugger trying to find where this 7A00 is. And here is the entity ID. So there should be another value further down here that is the same thing, and I don't see it. And I'm not sure why. I guess that's not terribly important at the moment. So we have a factory, and then we need to see what the factory update, and I don't know what the factory update is, and so we can look for E entity factory. That should actually be in the entity update table. So entity ent factory. So we'll look for that function now. And we can set a breakpoint for that as well. It's right in the same file. And yeah, so there's going to be some additional complexity here that we do need to figure out. So let me go to so the first thing we do is take params, and params was at 7A00. If I remember correctly. No, we're masking the lower. So the params is 0. So the blueprint that we're looking for is 0. So our data index is 0. So we can look at look for these factory blueprints. And they're in the same file too, but I'm going to open it in this tab. No, they're in. So these aren't pulled out yet. So I'm going to look for those in the ASM. They don't show up there either. So I'm not sure. This may be in a data file that we're not decompiling at the moment. We can look at the symbols for US and see what this is. Not there. So it's not showing up in symbols either. And it's just noted as intern. Let's do this. So there's no reference to it in source. And no reference to it right now in ASM either. And it is, so it's assets that get pulled out. So let's look at the assets directory. I haven't spent any time looking at assets at all. And D1, maybe factory blueprints. Yes. Okay, so our offset here is 0. And let's see if we have this address. Unfortunately, this is coming from a file, again, that's not decompiled. So we can look at this in DocStation, we'll have it. So AD1D4. Sorry, I had the debugger in front. So if you were trying to follow along, you would have had some difficulty. AD1D4 is where I'm going. So we're here, and so we could start taking this data, and it's being treated as a this is being treated just as an array of bytes. It may be something that we can pull out into a struct, possibly, but we can kind of go through each one of these things. So first, we can't pull it out into a struct because of the way that it's being loaded. We have this pointer, and we're kind of incrementing this pointer as we go along. So the first thing is this child ID. The child ID being pulled out is hex 80, so 128. And then the next value is this unknown 4A, which is 2. Followed by the same index but masked, just the lower 6 bytes. And so that's going to be 0. And this is going to be 1. We're still operating just on that same byte. Now we're going on to the next byte from the 80. Oh, drat. I did the wrong thing. These are all going to be 0. 1d4. The second value was 5. This value was 2. And then C1. My eyes are going. So C1, the top 2 bits are set, and then the lower bit is set. So this is going to be a 1, and a 1, and a 1. After the C1 comes at 2. And then the lower 4 bits is going to be 0. And the upper 4 bits is going to be a drat. I screwed that up. I think it was F0. No. 20. And then 0. And we have our we finally have our data. So then we go through and do a bunch of stepping, muck with the player a little bit. So that's step 0. Unknown A4, we found out was a 2. So we're going to set our position based on the player position. And then we're going to break, and then we're going to go down and do this. So unknown A4 again was a 2, so we're doing the same logic, setting ourselves based on the player position. Unknown 9A was a 0. So we don't do anything with that. Unknown 9A seems like a timer, possibly. Nine 6, I believe, is a 1. So our N is 1, which is a little surprising because there's, I think, 3 Z's that come up, so I'd expect this to be a 3 or something higher. But this finally is where the new entities from the factory are getting created. Different logic for determining which range to get entities from. Whenever you get a new entity, there's some destruction logic that happens to clean up the old one that was there. And here finally is what I was interested in. How does the new entity ID get set? It's the child ID plus this unknown A8. And A8 we already determined is not getting set. So it's just the child ID. And where is the child ID set? Child ID is pulled from here. So our entity ID is going to be 2, and we can go back to this table to see what entity ID 2 is, and it's this function with an unknown utility. And so somebody else has come through and noted that this is used for a lot of different things. And unfortunately, that doesn't tell us a whole lot. So I think that's all I'm going to look into for now for how that the Sleep Z animation works. What I really want to do is kind of reverse engineer how that's being set up so that I can replace it with the life up behavior and animation. I've gone through, so looking at what are the things in the game that give you additional life, so like Muramasa. I looked into that a little bit as well, and the weapon code for Muramasa seems to just be concerning itself with the animation and things related to that. So I need to look at some of the items, like the food items and potion and things like that as well. So that's all I'm going to do around this for now. I will shut all this down and then move on to, or get back to Doppleganger. All right. So where were we on Doppelganger? I'm not going to go back to the function that I was working on yesterday because I don't think I'm going to make any progress. I didn't look at it at all last night. And I'd rather do something that I hopefully can get finished today. All these tabs are open. When Safari fails, it fails in interesting ways. So we have a door function, which is interesting. It doesn't match. It matches N01, but doesn't match BO4 or Doppelganger 10. So RBO5, if you're not familiar, is Doppelganger 40. BO4 is Doppelganger 10. And what I'm doing now is looking for functions that have not been decompiled yet, but will affect possibly both of these. And I'm gonna start a. Oh, sorry, I still have a lot of stuff in the way. So this is our duplicates report. It finds functions that are similar to one another. And so a lot of the functions in BO4 and RBO5 are going to be the same. In the background, I'm going to start a clean build so that I can find what function I want to work on a little more quickly. We don't have size or anything else in this table. It'd be nice to have a little more data here. But what I'll usually do is find some of these and then kind of cross-reference them. These ones further down have not been decompiled. We have another case here where there's an NO1 function that's in both BO4 and RBO5, so that's probably worth looking at. This may actually, so NO1 is outer wall, and that's where Doppleganger is. This may be something that is in BO4 outer wall, or Doppleganger 10, because Doppleganger 10 is in the outer wall, and then maybe was mistakenly copied over into RBO5, even though it's not relevant, but maybe not. So let's look at that one. It's been decompiled already, so we have some foundation to go on. I'm going to look at that function first. That's in typing a func 3D8AC, and our function is AOC, A0C. And a lot of times with these, so the duplicates report ignores globals the way that it's written. So we don't have to worry about those, but occasionally there are things, for example, related to the player. And I don't see that here. That's what I thought this was going to be, was something player related. It doesn't seem to be, though. So it just seems like a function. It has an entity that we don't know what it is yet. I can't remember if I decompiled this or somebody else did. But we can look at that and see how similar it is. We have some foundation to go on. So here is the BO4 version of this in assembly. Yesterday it was, somebody asked, is 123T asked, why don't I use IDA Pro? And I didn't know. I didn't know why I didn't use IDA Pro. And so I thought that I had downloaded IDA Pro in the past. There is a free non-commercial version, and what we're doing is non-commercial. So, though, I guess what I'm doing on the stream is commercial. But I wanted to look at IDA Pro and see if it would do anything for me. And with the free version, you only get x86 and x86 64 support. So no, it does not do anything for me. PlayStation and PSP are both MIPS. If we looked at the Xbox 360 version, that's PowerPC. If we looked at the PS4 version, the x86 portion of it is going to be just the PSP emulator, and that's my understanding is the PSP emulator is like the Sony proprietary, like backwards compatibility library emulator, which would be interesting to look at, but not really certain. And then on the mobile ports, the game itself is the PSP version, and so you have all the MIPS binaries. And then the mobile ports are the same thing. They're a PSP emulator playing the PSP binaries. And they're ARM, even if they wouldn't be. It would be ARM, and so the free version doesn't cover those. So the hobbyist home edition is $350 some. I'm not gonna look into a license at the moment for IDA Pro. So then I decided, what about Ghidra? Go back to Ghidra and see what the support is there. I might do some Saturn stuff. There's been some work done in the last month on Saturn to make it a little bit more straightforward. And I might look at that as well. So I'm going to take the N01 version of this. I need to do a few things. I need to go grab this entity extension and define these variables. And so our globals are going to be wrong, but we can get something matching with the wrong globals and then convert those over. So I need this 8185C, which is a signed 16 array. So yeah, I looked at Ghidra, and that the output that it produced, I didn't think was any better than what M2C produces. So I don't think that provides any advantage either. All these are coming in as static. I'm going to change them to extern. And there's a couple of them. Actually, I'll just grab all of these from this file, and I can muck with them here instead of going back and forth. So now I just need the entity extension, so I do have to go back, and that's because my context, so the way that decomp.me works, if you haven't seen it before, you have a context which acts basically as your header file, and then you have your source code that you're editing. When you compile, it brings in this context as well as what you have here to produce some output. On the right, you have your target, which is what was uploaded, as well as what is being compiled. Since this is not compiling at the moment, the current output is empty. So I need to find this ET. So this was a struct that's specifically used in this function as an entity extension, not used anywhere else that we know yet. So I'll add it here. My context, we have makefile targets to generate a context. I haven't updated mine in a while, which is why this doesn't exist yet here. But it's simple enough to add. So this gives us a 95% match. Like I said, we're going to have some globals that are mismatched, but we can fix those pretty easily. And so I'll just kind of go through one by one, doing search and replaces until those are resolved. And as we're doing that, eventually we're going to come to some what did I do? Is this in context? Hey, is 1, 2, 3. If you weren't here, you just missed my. Yeah, I just talked about IDA and why it ends up not being helpful, at least for me. It may be helpful to others who own a license. I don't own a license, and so the free version only does x86 and x86 64, and we need MIPS. So if you would have come 3 minutes earlier, you would have heard all this. But anyway, I looked at Ghidra as well, which I've looked at before for this project, and the output just wasn't significantly better than what M2C produces. So there are some projecty things that I think Ghidra may be useful for, but I'm happy with this tooling right now. So we have a few things here that are different. I understand. I like to keep things on the up and up as much as possible, especially if I'm broadcasting it to the world. So I have 1 million copies of Soten on my shelf next to me. All right, so I've seen as I'm going through this a few places where there are differences. We'll get into those in just a second. While I'm cleaning all these up, I'd like to just finish. So that's all finished. Things like this, where there's immediate differences between GAPI and the symbol here. The symbol here is a convenience symbol for us to identify the struct access that's required there. It would be based. What there? I had a thought about something like that. Drat, and now I can't think of it. Oh, there was another game. Oh, yes, that's what it is. There was a request on YouTube to cover Splat. And one of the things that I think is difficult about covering Splat, I could, and I'll do this. It's not a huge deal to do it. I can sit and write a Splat configuration for any of the Soten overlays and get it integrated and it'll work fine. But that's because all the build infrastructure is there already. We know what the compiler is. We know what the SDK was that was used. And so all of that's there already, making the Splat portion exceedingly easy for Soten overlays. If I was going to start a new project, I would have to go through and create a new build chain, figure out what the correct version of the SDK was, what the correct compiler is, any flags that are necessary for the compiler. Others that are working on Soten Decomp have done that for other projects, and so it's possible. It's just something that needs to be done, and that takes work. And so it's not just Splat; it's Splat plus all the build tooling to produce a matching decomp. And so I thought, if I was going to do that, what would I want to do it for? And not a PlayStation game, but a PS2 game. The Neo Geo Arcade Classics was one of the first things that came to my mind. And that's because I'm reasonably certain in that bundle is a Neo Geo emulator. So you'd be decompiling a Neo Geo emulator, which I think would be a pretty cool piece of software to have. Basically, SNK's, official Neo Geo emulator. I don't know if anybody has gone through and done anything like that, but I think that would be kind of a cool project to undertake as well. All right, so I'm looking here. I'm going to do a few things to try to determine what might be happening here. We are accessing this field, but then we're also loading another field, offset 2C. And the value 64. So we need to figure out what is going on there. I'm going to look at the M2C decomp, find case 1, and see what case 1 has. And it looks like all it's doing is assigning a value here that isn't getting assigned otherwise. So we can add a new value at offset 16 in this AOC structure. I don't think we went through and figured out what this entity was. So this is going to be at 8C. And it's going to be assigned 16, so we're going to have to do some work here. We're going to have to add a new value at 8E. And then we can turn this into assigned 16, unknown 8C. And then assign that. And I need a semicolon. Need to capitalize properly. And so let's find our line 65 here. So we're pretty close. We just have a branch that's going to the wrong place, and I think that's because we have something similar elsewhere here. So here we're reading at offset 9C, which I believe is the next entity, instead of reading from this global. So let's, again, I can pull an arbitrary field here, so we can look at 8.4 and see what the offset is that we get and how close it is. Actually pretty close. 9C, though, is going to be past the end of this entity. So an entity is BC in length. So 9C minus BC is going to be 10. Oh, no. 9C is much smaller, sorry. Is it 8C in length? Let's look. Confusing myself. No, it is. So this will be part of the entity extension as well. So we can go over to the context, and yeah, we have 9C. Actually, we have a field for that already. And so hopefully it's a half word, unsigned half. Is that right? Ooh. No, so this might be something different. I'm going to try to reuse this one, and we'll see. N01, I'm not sure if this is decompiled for PSP yet. Oh, it does get loaded as a unsigned because of the mask. So that's fine. Okay, we can keep going. So then we're going to be doing a minus on that. And is that unconditional? There we go. So I'm just following these. So this looks like it's a timer, and we can look at where this was used on in the NL1 code and see if it's a timer there as well. Let's do that. I'm interested in what this might be. I'm going to wrap this in quotes. Oh, we have the same thing. So it's being used the same way, both here and in NO1. And we're really close, so we're at 45 edits to match. 45 is odd. Usually the number of edits to match is going to be an even number, and that's because the things that are different are going to be these immediates, and they're going to come in pairs. So there probably is one more thing that needs to be fixed before I can try integrating this, and I just need to find what that is. I'm going to save this. So we have an immediate there, and here it is on line 68. And that was my fault. I added a whole new field when this seems like it should have been this unknown 9C. May have been a senior moment. So the 8C I can get rid of again and move that back to padding. And that means I didn't have to change this structure at all. It just worked the way it is. So the other thing I don't know is how many of these declarations do I need? Gotta pare those down as much as possible. So far I need them all. And I think I need those as well. So this came from BO4. Let's look at BO4 and see if we can find what this is. We need to give ourselves the right function name. And so in BO4, we think that this is doors. It is something that I've noted is hit during, excuse me, while we're entering. This 458 has been declared already. Yes. As well as 5CC and D4. Yes. So let's build and see. 040 is already defined. That's because I didn't get rid of the include ASM. And BO4 is still matching. So let's go and do this for RBO5 as well. So none of these have been pulled in yet. The RBO5 function was VOC. So this guy here. The big deal here is all of our globals, the names are going to be different. So it's going to be a little painful. What I think I'll do is get the correct global names from decomp.me because it's a little easier to match them up that way. So I'll create a new scratch for that. Boss RBO5, non-matching doors, and then VOC. It would be nice. Sometimes I'll write comments in here, but it would be nice in decomp.me if there was a way to say, oops, that is not what I wanted to copy. That these functions are friends, but there isn't. I'm gonna have to do some of the same things. I'll probably just grab the context from here and copy the whole thing. And copy this implementation. And so now my all my constants are going to be wrong again, or globals. So let's go through and do the find and replace on all those. And then it should work in RBO5 as well. If I had the patience to figure out what the meaning of all these were, I could go through and give them real names, and then giving them real names would eliminate the need to do this, but at the moment this is more expedient. And when we're done replacing all these, we should get the same difference of 40. Based on when I was looking at IDA Pro yesterday, I'm not sure if it is, but based on the feel of it, it seemed like it was a Java app. And reversing a Java app is a little different from this. In some ways it's easier because it's bytecode, and the optimization happens very late, basically at runtime. And so you can actually get a lot of information from the bytecode. Oh, I need to hand edit some of these. The addresses overlap, and so I'm getting duplicates up here. So this FC should be E4, this first one on line 75. And then this E4 on line 110. And there we go. So now we're at 40, which is what we need. And so we can go to RBO4, or RBO5, sorry. I always say RBO4 because it's BO4, but it did not work out that way, that those match. And make this. I need to include the correct header, which is going to be the RBO5 header. The common header is used when generating these files, and it has just what's the minimal amount necessary to support include ASM, but really nothing else. So this works here as well, which is nice. So this is a function that exists in, I'll write a little note here, but this, actually it's probably not necessary because the dupes report will find this, but it's a function that, a door function that exists in an outer wall Doppleganger and Doppleganger 40. The Doppleganger 40 part of it is a little odd because Doppleganger 40 is in the reverse catacombs and not outer wall. So a little different. But we got those done. That's good. Little closer in both of them. Let's look at what is next. I'm going to do this a little differently. I'm going to do a find in RBO5 in the non-matchings and looking for .s's. And so there's functions like player step walk that are not, they've been matched. Oops. Let's look at that and see how close. Memcard set port is another one. Definitely the wrong name. It's a relatively simple function. It sets 4 globals, which is what Memcard set port does as well. But this name doesn't match. It just was a function that did the same, had the same behavior. But let's look at the step walk and see what that looks like. First I'm going to look at the dupes report. So this looks like a pretty simple function. It's in DRA, so this is a function used for Alucard. And so we can open this file in DRA and see what this looks like. And this is a pretty simple function. My guess is the only difference between these is going to be possibly what this value is that's being passed, and then maybe these functions, but all of those should be pretty simple. I'm going to grab that. This one, I'm not going to use decomp.me. I'll just do it manually. We'll do it live. So that for RBO5, that is in unknown 44954. And I'm going to open up the assembly to get what the correct symbols are. And then we can see if there's anything suspicious as well. So this is our function. And sometimes I like to chain these together. So we have 2 functions down here that we don't know what they are. So let's figure out what those are at the same time. And then this constant 4301c, that's up here as well, 4301c. So that looks fine. So I'm expecting this to work, and it did. And then we should be able to do the same thing over here on BO4. And it's going to be the same process of checking the assembly to get the right functions. And so what does this do? And could it be better? Those are questions that we should ask while we're doing this. Let's see if it matches first. It doesn't match. That's because I pasted the wrong thing. The first function was right, this one was wrong. So an interesting thing, if you're not familiar with older versions of C, you don't need to have declarations necessary for the functions that you're calling. So there are times where I could add just about anything here. This will fail at link time, but it'll succeed at compile time. That works as well. So how could this be different? Do we treat these functions as returning a Boolean? And maybe we could find where that function is declared in DRA. Oh, okay, the return value is not being checked. Sorry, I thought the return value is being checked. In this case, we don't need to care. This function looks like it isn't decompiled yet. I don't remember doing this for doppelgangers, but it looks like that would be a straightforward one as well. We have globals here and down at the bottom that would need to be mapped, and then anything referencing the player gets changed to Doppelganger. But other than that, that probably is going to be a straightforward function to switch. Yes. Hey, Rama, be good. Good to have you. Yes, so we're using checksums, and that's the primary way. Just the SHA-256 of the original. When we're looking at decomp.me, it's telling you along the way. The big thing that we need to be cautious of, and I covered this a little bit yesterday, and it'll be up on YouTube in a couple days, but we need to make sure that when things compile, that not only is the code that's being generated identical to what was there originally, but that it's placed at the exact offset. And so yesterday I was working on something where, depending on what file some string constants were put in, I could get them to align properly or not. And still haven't solved that issue yet. There's some string constants in a file that is unrelated, and I'm not sure why yet, but hopefully we can figure that out. All right, so this player step walk, I'm going to check to see if this function is... So usually we don't call functions in any of the stage overlays. We don't call functions directly from DRA. They'll be like the G API structure, which that's at a known place in memory. It has pointers to all the functions that we need to call in DRA. So my guess is that this function is named in the pattern of a DRA function because it's a matching duplicate. And that does seem to be the case. So we can do this one. That should be an easy one to do as well. Because like I said, I think it's just going to be globals and switching player to Doppelganger. So I'll go over to decomp.me for that. Create a new scratch. So we know what the signature is for this. And so I like, when I can, I like taking that signature. And that's because M2C will use that. And it just gives M2C a little more, a few more hints to get the correct thing. In the background, I'm copying the DRA implementation. And we need a few, it looks like just this one global. Which is an unsigned 8. And so we have, there's a few more global symbols that I could map that we probably have now. So velocity Y, that gets mapped in, and so we get a nice symbol for that. Velocity X, I haven't mapped that yet. And so we can grab that, and that might be nice to get. G player, instead of G player, VRAM flag. This is, it's in the 7.6. So this GDOP, I believe. So okay, let me back up a little bit. Anywhere there's G player. Oh yeah, okay. So this one's correct. We're going to replace that with GDOP, and GDOP is a player state object, just like GPlayer is, but it's for Doppelganger, so it's in a separate location of memory. And then any of these players are going to get replaced with, this is a macro that goes to the first entity of the entity table. We're going to replace it with the Doppelganger macro. And we'll do player dot so I don't miss these. And I need to grab that macro. That macro is just going to the first entity that belongs to the stage. Oh. Try to be careful with my search and replace, and it still broke things. G. This should be GDOP. All right, so the constants, all of these constants are going to be off. But it does give us the opportunity to map these as symbols, and I'm going to take that opportunity since I have them. I like to do this as they come up, because then when I have other code that is going to reference those symbols, they will be there. And you can look at the other Doppelganger. I don't know that I have any of it. I must have GDOP. No, I don't have GDOP. Excuse me. GDOP, I can't map that because it's not in a shared address space. It's just in the stage address space. I guess I could, yeah, I could do that for BO4 and then for RBO5 as well. So let's do the Doppelganger ones here. So really I'm just looking at where I know that this is the velocity X field. I'm going to take the address that came from the disassembly and give it a new symbol name to match. I'm going to spell that Doppelganger correctly. So that's going to be velocity X, and it's going to be set to the address of that other symbol was an automatically generated symbol with the address in it. And this isn't going to help with this decompilation at all, but it will help in others in the future. And so anywhere I see something in this 807 range, that's going to be possibly something that I can map. So this is down on line 24. Sorry, I was looking at this one here, which we have a address for as well. And we can't map the field path directly. We have to just give it a symbol name. So we do that with underscores, replace the field access with underscores, which is enough of a hint. Unfortunately, we use underscores in some of the field names as well. And so that that can cause, and some of the variable names. All right. Any others? Some of these other ones I have to map for each individual stage. So one for BO4, Doppelganger 10, and one for RBO5, Doppelganger 40. I will fix this global. So this was the global address for Alucard, and replace it with the Doppelganger 10 address. And that's really the last thing that I need to do here to get this to compile and match, I believe. No, one more thing. There's not quite even. And I'll tell you why in just a second. There's a curious difference between Alucard. Oh, switch. There's a curious difference between Alucard and Doppelganger. These values are different, and they are different. But this tells us some things that I hadn't found yet for Doppelganger, and will help again in the future. So let's do the PL VRAM flag symbol. So that's in a different symbol table, one specifically for BO4. PL VRAM flag. Our linter will come through and reorganize these. So I could put them in order, but the linter will come through and do that for me. So I'm not too worried about that. And is there another? Previous step. And another. I think there's one more. Oh no, I did the wrong thing there. Wrong address. That would be bad. Getting these wrong is a huge pain to fix. So try to be as careful as possible. It's not insurmountable, but it when you map a symbol to the wrong address, it becomes extremely confusing when you're trying to decompile why putting what the correct name for that symbol is no longer works, and debugging becomes significantly more difficult. All right, so I still have a bunch of name or constants that are wrong. So this one is coming up as a 0. There was another one here. 6, 5, 4, 3, 2, 1. All those are wrong as well. And that's because this switch is based on the player steps. And Doppleganger has many, if not all, of the same player steps, but the values are all shifted by 1. And so we can't just use the same macro or same enum for both of them. We have to create a new enum. And I don't know if I have that. I don't have that enum, and I have to modify it anyway. So each of these, I'll try to spell correctly, but, oh, and actually I just call them Dop. So each of these I'll switch and do them one by one. So unmorph bat looks like it's going to be and so basically each of these values I'm trying to line up what the order is in the jump table and how this whole section gets created and generated by the compiler. The ordering is going to be all over the place. So I can't necessarily trust that the order that these numbers are going to be in is the same as the order of the switch statement. But that's okay. So let's see. So some of it's a little trial and error. And so what I want to see is now my 2 lines up. So I think that's good. I have jump already. I don't have fall. So I'm going to assume that fall is 4. And then those line up as well. And my 0 lined up. So I think that is good as well. So, oh no, it didn't. My 1 and 0 are not lining up. Did I get them all? Let's look at the decomp and see what it came up with. So it didn't even generate a switch. It just generated the conditions. So a little messier. So I need to find this A0. And I'm going to do that by adding a case 0 to each of these and seeing if that alignment works out. So far it's not. I'm going to add that to the default as well. It doesn't work out there either. So where is this 0 coming from? Somewhere we have a 0. Oh, is it here? I'm missing something. Oh, player stand. That's where it is. So we have a bunch of these, and these are shared between both Doppleganger 40 and Doppleganger 10. Yes, did that work? Oh, player stand should be 1. There we go. Or Dop stand. So let's look at the rest of these then and see if all we have left is these global offsets. If that's the only thing that's left, I'm pretty comfortable with this, and it should match. That's all I see as being different. So let's try it. So first I'm going to take this. I don't have my chat helpers telling me that I'm on the wrong screen. Sorry about that. My window management could definitely use some improvement. So I have this new Doppelganger Steps enum, and I'll replace the old one with that. We don't know yet which step is missing, or I haven't looked closely enough to see which step is missing. But that should be enough to get this function in now. And then the only global that we had was this one. So this should basically work unchanged except for that one global in RBO5 as well. And that worked. And so let's find that 570 function here. And so there's a couple ways that I could do this. If there already is a symbol that's the same name, this will compile and it'll link and will fail. However, there's no symbol name the same as that. So when I'm really lazy, that's what I'll do. I'll just let it fail and then look at the diff and use that. So to get this symbol, it basically is the last thing that's being used in the function. So I'm going to go all the way down to the bottom and grab the last symbol. that should work as well. Oh no! I missed one. I thought there was one more. So this becomes 3 AC. And that works. So one of the things that we did was edited a bunch of global symbols. I did them for BO4, but not for RBO5. And if I would force recompilation of all of the C files, this is probably going to fail at linking. And it didn't because reasons. Why wouldn't that fail? I'm not sure why it didn't fail. I would have expected there to be symbols that were missing, but they weren't. Oh well, a mystery for another day. So we were able to get, what, 4 or so functions decompiled? 6 functions decompiled. And a bunch of new symbols added, which is nice as well. There was one more in here. Let's look at that. In the same cluster of functions, in the player walk step, is that step walk? Yeah, player step walk. So we did 570. Let's look at this 040 as well and just get a sense of what that is. I don't think I'll do that today because I'm running out of time, but I would like to know what the complexity of that is, and if that's something that the complexity of these paths is what's killing me. If that's something that would be straightforward to take on next. It's a little longer, but not terrible. Add window management again. You dig down deep, good to have you. Do you two know each other? Nope. Or so the Germans would have us believe. All right, so I'm going to look at this one more time. And see what this looks like. So a little funky. Definitely some twisted logic. My guess is that looking at the PSP version will help quite a bit with this, and it won't be as bad as it looks. All right, so we've been decompiling Castlevania Symphony of the Night. If you want to know more, soten.z.dev is the place to go. You can find a link to GitHub and a link to the Discord. I'm going to clean up what we did today, and I will post a PR later today. And so if you're watching on YouTube, by the time you see this will probably be checked in. And if you want to know more about how to do this or what to do, keep watching. Monday through Thursday. I live in a civilized place without the insanity of daylight saving time, so I didn't realize that the rest of the world was an hour different. So I'm an hour late today, but usually 11 a.m. Pacific Standard Time. Maybe next year you guys can get on the right timeline. But I'll be back tomorrow. I'm not sure yet. This week's schedule is a little funny anyway, so. Oh, Europe hasn't changed yet. Good. That's right. I was accommodating all the Europeans. If you want to watch more, please like, subscribe, and I'll be back tomorrow. Good to have everybody in chat, as always. Appreciate it. Adios.